Now we have what's called the change of base formula. So make sure you know that because I will ask you about that later on. The change of base formula is when the logarithm doesn't work out very nicely. For example, I'm just going to do part C because that's the easiest one. If you were to ask yourself, 3 to what power gives you 7, it's not really easy for you to come up with a solution. Because I know 3 to the first power is 3, 3 to the second power is 9. There is no way we can get to 7 using whole number exponents. So when it doesn't work out nicely, like what we've seen in the notes so far, you have to use the change of base formula. So what you can do is you take your logarithm, base b of x, and you rewrite it as any logarithm as long as it has the same base, or any common logarithm, or natural logarithm. You just need to make sure that it's log of x, so what we're taking the logarithm of in the numerator, and then log of the base. So the base needs to go in the denominator. I like to use the common logarithm that has a base of 10 just because if we're plugging it in our calculator, you do have a log button right here. It would be just as easy to use the natural logarithm because we have a natural logarithm button right there. On a TI-30X, you are not able to plug in a log base, let's say 3 of some number right away. You can in other calculators, just not this one. So let's see what that would look like. Like I said, I'm just going to use the common logarithm, and I'm going to do part C since we're already on it. I can rewrite this as the common logarithm of x, so what I'm taking log of, 7, over the common logarithm of the base, which was 3. In my calculator, what I would do is log of 7. Make sure you close that parentheses and then divide by log of, in this case, we had a base of 3. I'm going to close that parentheses once again. I like to go 3 decimal places. It even says in the directions to round 3 decimal places. Remember, if the fourth number is 5 or greater, you need to round that third number up. So I'm going to put 1.771 because 2 is not 5 or greater. So it's 1.771. That's an approximation, so I'm just going to put 2 squiggle lines. That's how you denote approximation. If something is exact, you would put an equal sign. Let's take a look at part A. So log base 32 of 8. If you were to ask yourself 32 to what power would give me 8, it's not going to be a nice, simple answer. So instead, what I'm going to do is log of 8 over log of the base, which was 32. If I plug that into my calculator, I have log of 8, close that parentheses, divided by log of 32. I get exactly 0.6. So it equals 0.6. I didn't have to round. I don't have to use approximation notation. That is the answer. Okay. Why don't you try B and D and then hit play to check your work when you're done. Part B, the answer was exactly 1.5. Part D, the answer was approximately negative 1.048. So in this problem, we had to round up because we had negative 1.0479. 9 is greater than 5, so it would boost that 7 up to an 8.